Topic here. Next 2 units, all we're doing is talking about triangles. Three-sided figures, that's it. All we're doing this unit and unit 5, talking about triangles. So what I want to do today is, how do you name a triangle? All right, there's all these different types of triangles out there. How do you name it? First way I'm going to show you to name it is if you know information about their sides. I know nothing about their angles, but I know everything about their sides. So there's 3 types of triangles based on their sides. First one, notice I have those hash marks coming back. We really didn't see those in the parallel line unit. Hash marks mean what? Congruent. So all 3 sides are congruent. Anybody know what that type of triangle is called? Equilateral. There we go. So if all 3 sides are congruent, we call it equilateral. All 3 sides. All right, next one. Only 2 sides are equal. The third side is not equal to the other 2. Isosceles. Yes, isosceles. Again, this is only if I know information about the sides. I can call that isosceles when 2 sides are equal. And then notice I didn't put any hash marks on the third triangle. That's because no sides are equal. Scalene. Yep, good. Scalene. That's only if you know information about the sides. All right. What if I don't know any information about the sides, but I do know the angle measures? What are these arc marks telling me here? They're all 3 are equal. All 3 are equal. Now, could I call it equilateral? Sure, because that does mean all the sides are equal. But if I see all the angles are equal, here you go. And this is a nice word to say. Equiangular. Equiangular. And let's take it up a notch too. Can you find me what those angles are? If all of them, anybody know how many degrees in a triangle? This is going to come up pretty quick here. 180 degrees in every triangle. And if all 3 angles are the same, they each have to be 60 degrees. Yep. So anytime all 3 angles are equal, they automatically have to be 60. Equiangular. Equiangular. Got all your new notes packet, piece of graph paper over there. All right, let's go to the next one where I just put 105. You don't need to know the other 2 angles. I think we did this in Unit 1. Anybody remember what type of angle 105 was, bigger than 90? Obtuse. So this is called an obtuse triangle. Yep. If it's got one angle bigger than, can it have 2 angles bigger than 90? No, because it goes over 180 degrees. So all you need is 1 angle bigger than 90 to make it obtuse. Down here, next one. You see our symbol there. So this is a, what's that symbol for again? Right angle. So this is a right triangle. Yeah. We could find the missing angle here, right? If that's 70 and 30, what do I have? 100. So how many are left? How many degrees are left over for the third? 80. I didn't need to know that. But if all 3 angles are less than 90, acute. This is an acute triangle. So these are the 4 different ways we can name a triangle based on its angles. Angles. All right. All right, let's keep going. Not much to do today, just a little intro to triangles. I am going to start using some vocab from the past. Point M is the midpoint of JL. Can you put markings on the diagram? If M is the midpoint of JL. M is the midpoint of JL. First person up today, give me 2 segments that are congruent then. If M is the midpoint of JL, which 2 segments are congruent then? M is the midpoint of JL. Which 2 segments do I have congruent? Started off right, Jayla.
J and M and M and L.
Darn right. JM and ML. So it looks like what? All 3 are congruent now, aren't they? Because I was given those 2 are equal. Now it looks like all 3 of those sides are equal. Perfect. Classify JKM. We name a triangle based on what's called their vertices. So does everyone see where triangle JKM is right now? JKM, this one over here on the left. All right. Is it equilateral, isosceles, or scalene? Well, we're not ready to tell yet. Okay, we're not ready to tell. I told you JL was 1.5. Jayla just told us JM and ML were equal. Find their lengths then. If the whole thing adds up to 1.5 and these two are the same length, find the length of JM and ML for me. Because I don't know if this is equilateral, isosceles, or scalene yet. What's got to be the length of JM and ML? They're both congruent and add to 1.5. Let's keep it rolling here. Izzy? 0.75. So this is 0.75. This is 0.75. And didn't we just say all three segments are equal? What else is 0.75 on this diagram that I can label? Those two, and what else here? Where are we going with that? Taylor? KM is also 0.75. Now you know all three sides of triangle JKM. What type of triangle is it now? Okay, JKM. Take a look at their side lengths. What type of triangle do I call this from the first page there? Aiden? Equilateral, yep. So this is equilateral. And it does say explain your reasoning, so we'll put equilateral because somebody give me a good reason. Had Hayden know it was equilateral. Good explanation. Jayla, back to you. Done. All sides are equal. All sides are the same length. All sides congruent, however you want to put it. Questions and how we got there. All right, next one. This is an isosceles triangle. I've marked the congruent sides. Find the lengths of all three sides. Real quick, just to make sure this never happens again. Are these the sides or the angles I've given you? Sides. So we're not adding them up and setting them equal to 180. What's 180 degrees for? The what? The angles. All right. This is not the angle. So don't let me catch you adding them up and set it equal to 180. I give you all three sides, but I don't need them. I don't need all three. What are the two that are congruent up here? What are the two sides that are the same length up here? Here we go. Rowan, the two sides that are the same.
4x plus 1 and 5x minus
4x plus 1 is equal to 5x minus 0.5. I don't need the 9x minus 1. All right, just because I give it to you doesn't mean, hey, we're going to use everything here. That's a proof. All right, we're going to use all the givens. All right, go ahead, solve for x, and we'll talk. When you have the value of x, let me know. Jayla, geez. 1.5. That's x. Unfortunately, some of you got caught on the quiz on one of the multiple choice questions. You found x and didn't read the problem and just circled that multiple choice, but I needed the actual angle. You forgot to plug it back in. X doesn't make me a winner here. X doesn't make me a winner. I need to know all three sides. Go back, plug it in. I need to know AC, BC, and what AB is. So take 1.5, substitute it back in for me. Where am I going here? Rahan. AC when you have it?
7.
7, good, thank you. BC when you have it. Where am I going there? Jonathan?
7.
I hope so, right, guys? We hope it's 7. Because it said it was isosceles with AC and BC being equal. And then AB, hopefully different than 7. Alex? 12.5. Got it. All right, everyone good? All right, I love this last one we're gonna do. I love it. Why do I love it? Because you're gonna hate it. That's why I love it. All right, find the lengths, find the measures of the sides of DEF, and tell me what type of triangle it is. So I'll give you guys a minute to graph it. Go ahead and graph triangle DEF, and we gotta talk. Oh, this is gonna be so great. Make sure you label the vertices too, D, E, and F. Find the measures of each side so I can call it scalene, isosceles, equilateral. Find the measures. How in the world am I going to find out what one of those things are? We're not using rulers. Are any of these sides horizontal or vertical? No, so I can't just count them. Ha! Ha! Anything we have available to us from this year that I'm probably going to need to bust out again to find the length of all three sides there? Keaton, what do I have with me? Say it nice and proud. Yeah! Distance formula coming back. It never leaves. Never leaves. Let's remind ourselves distance formula. Yes. Thank you, Keaton. Made my day right there. Oh, distance formula. I don't care. Here we go. Distance formula. Big square root. Inside the parenthesis. Anybody drop some knowledge?
Y. X.
Subtract your x's in any order. X2 minus x1. Order doesn't matter. Anybody coming up next? Plus, yep. I think you have it in the other parentheses. Do it to the y values. Squared. Okay, because I'm going to let you and your group do this and compare your results. Oh, just so everyone knows how I like the answers written here, the side lengths written. Let's say you end up with something that looks like this. I'd rather have 2 radical 10 than this long decimal, please, because that's how this is simplest radical form right here. All right, so please leave it in radical form. Do not give me decimals, because that's how it's going to be on the homework. All right, I'll give you guys 5, 6, 7 minutes, however long you need, in your groups to figure out. You are not doing, I'll do this side, I'll do this side, I'll do this side. Everyone does all 3 sides. Compare your results. Okay, compare your results, please. And then we'll decide what type of triangle this is. If it simplifies for you, please write that down. If it doesn't, just write the radical. No decimals though, please. Once everyone's done, take a quick peek with everybody in your group. Everyone get the same distances. If not, we'll have to figure out who's right and who's wrong. Make sure your X's are together, your Y's are together. Don't drop a negative sign on one of the numbers.
Wait, how am I still?
Which?
No, you're right. I did not. Yeah. You said two, right? Yeah.
Oh, I put it
Did you get three radical five for D? Yeah.
I got one.
Radical 113 for D.
Are we looking here? Ready to go? Compare our results. And then we'll decide what type of triangle is before we end the day. Side DE. What do I have there? Okay. Side DE or ED, whatever you called it. What are we looking for that one here? Rowan, what do you guys got over here? DE. Radical 113. Good. That didn't simplify, so we leave it as square root of 113. Make sure everyone's got the correct work down. Square root of 113 for DE. Square root of 113. All right, let's go FE. FE. Where are we going with that one? Lennon?
2 radical 26.
2 radical 26 looks good to me for FE. That's simplest radical form. That's how you're going to leave it on your homework tonight. 2 radical 26. Got it. And then finally, how about FD? FD. What are we looking at for FD? One more up there, Jesse. FD. 3 radical 5 looks good. 3 radical 5. Everyone all right? Any questions on those 3 sides? All right, now we have to determine what type of triangle it is. Now, the words acute, obtuse, right should not be coming out of your mouth because we only know the sides. That's based on angles if you're going to say obtuse, acute, or right. So just based on these 3 sides only, what are we calling this triangle here? Triangle DEF is what type of triangle, Jayla? That's two sides are the same.
Oh, scaling.
Scalene. Everyone, all three sides are different, aren't they? All three sides are different, so we have to say triangle DEF is scalene because all three sides are not equal. All right. The only time you can do acute, obtuse is if you know angle measures. Side measures, it's either scalene, isosceles, or equilateral. And you'll have one of those tonight on the assignment. That's why you have graph paper. Speaking of the assignment, let's get it going. You have your Chromebooks out. Open up the textbook pages and let's get going. Short day today.